fourth reporter for this afternoon, which I will tackle about grouting. So by definition, grouting is the injection of a slurry or a liquid solution into a soil or rock formation. The grout subsequently hardens, increases the strength and decreases compressibility and permeability. So, meaning ginapaligon niya ang strength sa isa ka ground surface through injection of a liquid solution. So, models of grouting. Permeation or penetration grout flows into soil voids freely with minimal effect. Compaction or controlled displacement. Grout remains more or less intact as mass and exerts pressure on soil. Hydraulic fracturing or uncontrolled displacement. Grout rapidly penetrates into a fractured zone created when the grout pressure is greater than the tensile strength of soil or rock. To better understand what are the models of grouting, here are some illustrations that are presented regarding these three models of grouting. So as you can see at the first model, which is the permeation or the grouting penetration, you can see it is like watering a plant below the water below in the ground surface. So mag-penetrate siya dayon. So next is the kaning sa compaction, controlled displacement. So and the next is the hydrofracturing and controlled displacement. So by looking at these figures in the presentation, you can easily determine what are the differences between the three models of grouting. Next is the grout characteristics. First is groutability. Next is stability, setting time, permanence, toxicity. So let us first tackle about the groutability. Groutability is to obtain the satisfactory performance, grain size distribution. It should be known because it shall show the relationship between the grout particle size and the void dimension. So next is pumping pressure should not be large enough for particles of soil to be disturbed. So dapat daw ang pumping pressure is dapat enough lang siya para dili pod ma-over pressurized ang isa ka ang ground surface. So next is grouting pressure is limited to 20 kN per millimeter squared. So naatay specified na grouting pressure which is limited only to 20 kN millimeter per meter per second, meter squared. So if ever man na maglampas sa 20 kN per meter squared is disregard na ning kanin sa number 2 na pumping pressure should not be large enough. So na kay disturbance when it comes to too much application of pressure in the ground surface or in the grouting. The quality of grout must be sufficiently fluid to enter the soil quickly. So there are specified qualities of grout to be able to be penetrated in the ground. So there are different kinds of grounds because there are different types of soil. So we need to choose different qualities or different types of grout that is applicable to the specific ground surface. The movement should not be too fast. So as in grouting, there should be a step-by-step movement wherein you could not skip a step, and also you could not move also too fast because moving too fast also affects the application of pressure, which sometimes the reason due to over application of pressure in the ground surface, which result to the term overgrouting. Rate of injection of grout depends on the viscosity of the grout and the permeability of the soil. So this is the two factors or wherein the rate of injection depends on. So we need to remember this. And also it also includes the shear strength of soil. So tatlo yung dapat natin tandaan when we need to remember that the rate of injection of grout depends on these three factors: the viscosity, permeability, and shear strength. Next is desirable properties of a grout. So, ano ba yung dapat nating piliin na type of grout na i-apply natin sa a certain ground? So, first is the suitable viscosity. Next is high viscosity for coarse and moderately permeable soils. So, just like I've mentioned earlier, that there are different types of soils that different types of soils na apply natin ng grout. So, we need to choose the appropriate type of grout to be applied in the proper type of soil. So next is the correct setting time. Next is the maximum volume with minimum weight. Next is the strength, stability, and durability. So these are the desirable properties of a grout that we must consider in choosing the type of grout we are going to apply in the grounds. Grouting methods. So in the grouting methods, we have first is permeation grouting, which is earlier, same definition as penetration. Next is the compaction, jet grouting, soil fracture grouting, circuit grouting, point grouting, electrokinetic injection. So these are the different types of grouting methods which can be applied in the different types of ground surfaces where grouting can be applied. Next is the groutability ratio, which is the formula. GR is equals to D15 times the formation, which represents formation, over D85, which is the grout. D15 stands for the particle size at which 15% of the soil is finer, and D85 represents the particle size at which 85% of the grout is finer. So this is the formula for the groutability ratio. Formation over grout. Lastly, the topic for this afternoon is the dynamic runoff. So, dynamic runoff. A runoff which usually water or even a moisturized landmass carries off sediments which piles due to intensive water flow. So, this is the only definition that we have surfed in the internet, and so the way I will going to explain this is through examples and through simulation which conducted by the American associations. So this is the name of the simulation that they have conducted, which is the dynamic runoff simulation in a changing environment. The goal is a data stream approach. So I will tackle about the highlights of the simulation for easier understanding to what have happened during that simulation and what is the reason why it is important in understanding dynamic runoff. So highlights is an instance-based data stream method is introduced for dynamic runoff simulation. The proposed method outperforms comparable data-driven and hydrological models. It provides a useful tool for runoff simulations in a changing environment. It is flexible to integrate various impact factors of runoff into runoff simulation. So, ito yung mga highlights dun sa ginawa nilang simulation, and these are the things that they have discovered after doing such simulation. So, the purpose of that simulation is, the basic idea is to view continuously arriving data of runoff and its impact factors as a data stream, and dynamically learn its relationship. To validate the effectiveness of the proposed method, we compare its performance with that of the three data-driven models, ANN, SVR, Random Forest, and 6 representative hydrological models, which is the SWOT, AWBM, SimHydro, SMAR, Sacramento, and Tank in simulating monthly runoff. So by the way, the simulation that they have conducted also is an important simulation, because this simulation lets us understand that lets us understand what really happens during the dynamic runoff. They have created a presentation or a graph presentation to further explain regarding the simulation that have happened. So this is the graph that they have made. So a newly arriving example. So rainfall, temperature, evaporation, and runoff serves as their main reason or the source or the cause of dynamic runoff. Next, they have divided the dynamic relevant base set into sudden concept detection and gradual concept drift modeling. So what explains this is that the sudden concept detection is that whatever is the result after this dynamic relevance base set, as you can see here in the evolving relationship learning, will give them an idea what concept they will do in order to create a new idea and update it back to the dynamic relevance base set. Kumbaga, trial and error lang ito. So dito rin sa drift modeling, ganun rin yung nangyari, na after they get an update, they will create a model or hydrological toolbox kung anong gagawin nila to be so cycle lang itong simulation na ito, in which they have been successful in determining the effects or in explaining what is dynamic runoff. So ano ba yung nagiging epekto nito dynamic runoff? In simple terms, kung masyadong malakas yung ulan and we have an excessive runoff like baha or ano ba dyan, it causes sediments to displace in lower areas. So ito yung dahilan kung bakit napupuno ng lupa yung mga mababang lugar. So let me show you an example, which is the latest example, an effect of Bagyong Agaton in Abuyog, Leyte. So as you can see, this is lower area, which is itong dito dati is nung hindi pa hindi pa nag-displace yung tubig or yung hindi pa nangyari yung dynamic runoff. This is a national highway. So because of too much soil displacement or land displacement, or ano ba yung term dyan, na too much flooding, so ito na yung nangyari after that. So ito pa yung isang example. Wait. So see, ganun din, no? So ito yung effects of this dynamic runoff. So for us to understand easily, let me recall the definition na excessive flow of water which sometimes a moisturized land displaced into lower areas. So ito yung nagiging effect niya. So that would be our report this afternoon. Thank you everyone for listening.